Okay, so we're going to take a look at solving a system of equations that, in this case, has a quadratic. Okay, so we have a system of equations. We have a quadratic and we have a linear equation. Alright, and we want to try to find any points of intersection of that system. Well, obviously, we could go directly to our calculator. And after plugging those two equations into our calculator, under the y equals screen, so x squared minus 4x plus 5 and x plus 11. Okay, we could create a graph, zoom standard. Alright, we could take a look at that graph, and there's our parabola, and there's our line. I'm going to zoom out a little bit so that I can get a better picture of what's going on there. So there's my parabola, there's my line, and it should be obvious to me that there are 2 points of intersection, okay? One here and one here. And obviously, using second trace intersect, first curve, second curve, let's go near that first point. Okay, if I hit enter, I get that as a point of intersection. Alright, and if I want to try to find the other point of intersection, do the same idea, first curve, second curve, move over to that guess. There's my second point of intersection. Alright. But I want to try to find those points by hand. So this is a system of equations, so I can obviously substitute. I can take one expression and plug it into the other equation for y. So in other words, x plus 11 equals x squared minus 4x plus 5. Okay? I'm looking at this equation carefully. I notice the x squared. I'm also noticing some x's. So let's start by getting 0 on one side. So that's going to give me minus 5x, and it's going to give me minus 6 over here because I subtracted the x and subtracted the 11. Okay? And now I can't use the radicals, again, because of the x squared and the x. I could use the quadratic formula, but fortunately for me, I know that I could also factor. So x minus 6, x plus 1. It's going to give me the solutions of x equals 6, x equals negative 1. Okay? So those are the x values. When I write my coordinates, those are the x values of my coordinates. Okay? But I still have to find my y values. Well, if I look up at the two equations from the beginning, I could pick either of those equations. I'll pick the easier one and replace the x with the number, and that gives me my y. Similarly, and those are my points of intersection. Oop, that should be negative 1 comma 10. Okay, so those also happen to match what I had on my calculator earlier. Alright? So let's try one more of those. Do y equals x squared minus 5 and y equals 4x minus 9. Okay? So I'm not even going to go to graphing this one. I'm going to go right to solving. X squared minus 5 equals 4x minus 9. Got those x's again. X squared minus 4x plus 4 equals 0. X minus 2. X minus 2. Oh, so this is nice because x is just 2. Right? I know there are two sets of parentheses there, but both sets of parentheses lead me to the same answer of 2. So that's my x-coordinate of the intersection point. 4 times 2 minus 9 is -1. That is my y coordinate, and that is the point of intersection.